All right, good morning. This is number 4 from the 2011 BC exam. I think there's a really good chance that you're going to have a question very similar to this on your exam this year. The reason why is this is something that can't just be plugged into a calculator. It requires some understanding of what's going on. So we got continuous function f, and f is graphed above. It says f consists of 2 quarter circles in one line segment. So we got 2 fourth circles and then a straight line, and the straight line creates triangles. That will be important for area. Now the tricky part, when it talks about g, this is a little twist on this problem this year. G wasn't just this open-ended integral. G was actually 2 of x plus this integral. So you got to be careful with that, and don't forget the 2 of x. So A, pretty straightforward, says, hey, find g of -3. The key to doing this is to actually write these things out. So g of -3 is 2 times -3 plus the integral from 0 to -3 of f of t dt. Don't skip that step. Actually write it out. The thing a lot of people will forget will be that -6, the 2 times -3 in there. So now looking at this, we need to find, it's a little tricky, this area. And the weird thing about it is it's 0 to -3. So the bigger number's on the bottom. In doing that, what I would do is I would go ahead and take the negative out and flip it from -3 to 0, f of t dt. That way you don't have to reverse all of your logic overall. All right, so I'm looking for the area from -3 to 0. So I'm looking for to find this integral. So I'm from -3 to 0. So I'm talking about this quarter circle. All right, so, well, a circle, remember, area is pi r squared. The radius here is 3. So that becomes 9 pi. But it's a quarter of that. So it's only over 4. So this becomes -6 minus 9 pi over 4. And so that's what g of -3 is. And you're done. If you didn't flip it like I did with that negative, you just have to remember that you're sweeping from right to left here. And that would result in any area above the curve to be negative, would be the difference there. All right, next is g prime of x. So g prime of x is the derivative, so the derivative of 2x is just 2, and then the derivative of an integral, so you take the upper limit and you replace the variable, you chain rule that. Since the lower limit is a constant, that's all -0, so we don't generally write the bottom part. So there's g prime of x, so g prime of 2, g prime of negative, what do they want? G prime of -3. G prime of -3 is just straight up 2 plus f of -3. F of -3 is the y value on the graph at -3, which is just 0. So my answer winds up being 2. I know, this is a 3-point question. So this was worth 1 point. And then g prime of x, correctly written and labeled, was worth 1 point. And then that final answer was worth your 3rd point. All right, B says, well, determine the x-coordinate at which the function g has an absolute maximum. So remember, absolute maximums can occur at endpoints or at critical values. Okay, so my critical values are where the derivative equals 0. So the endpoints would be -4 and 3. We'll worry about those later. But the critical values would be where the derivative equals 0. So remember, g prime of x is just 2 plus f of x. So where that equals 0 is my critical value. So that looks like f of x equals -2. So I'm looking for where this function's y value is -2. That's going to be like right down here. Okay, so I need the x-coordinate that gives me -2. That's the question. Well, it is a straight line, so we can use my slope here. So it looks like the slope is -3 over 1.5. So it's going to give me 5/2 as your x coordinate there. So that's your critical value. You got 1 point earlier for considering. So if you wrote this down, if you set the derivative equal to 0, you got a point. You get 1 point for identifying 5/2, okay? And then your last point comes from your justification. So to justify this, there's kind of different ways, but in general we justify a maximum by the fact that the derivative changes from positive to negative, because that means your function changes from increasing to decreasing. So g prime of x, and it's a little tricky. What's tricky about it is the 2. The 2 is what's making this problem weirder. If there wasn't a 2 there, it wouldn't be as difficult. The 2 is literally like a vertical shift down. And so that's why you can't just eyeball it and say it's, a lot of people would probably guess right here as your answer, but because of that +2 shifting this thing up, that's why 1.5 is not the answer, and it's actually 2.5. So g prime of x changes from positive to negative here. Now the endpoints aren't potential absolute maximums in this problem, and they didn't actually make you show what the endpoints equaled. But since your derivative is always positive leading up to this, it's always increasing, so there's no way that the -4 was your endpoint, which are going to be your absolute maximum. All right, so that's B. That's worth 3 points. I bet the justification part, that black line, is the most missed point on this one, because it's pretty tricky. All right, C. Find all the values of x for which the graph has a point of inflection. So remember, point of inflection is where the derivative changes direction. So the 2 doesn't change that, doesn't affect it. 2 is just a 2, so it's just a constant. So the derivative changes direction only at x equals 0 here. And the reason would be because the derivative, f prime of x, changes direction from increasing to decreasing. And on your AP test, actually write that out, from increasing to decreasing. That one's only 1 point, pretty easy. All right, D, find the average rate of change on the interval. So remember, average rate of change from middle school is just slope. So I'm looking for the average rate of change of f. So y2 minus y1 over x2 minus x1. So f of 3 is just the y value, so that's -3. Minus -1 gives me -2 over 7. So that's my average rate of change. That would be worth 1 point. There is no point for which the instantaneous slope is equal to the average slope. Explain why this statement does not contradict the mean value theorem. So the mean value theorem says, well, the instantaneous slope has to equal the average slope at some point on the interval if and only if the function is differentiable at all points. The problem is this function is not differentiable at all points. So f is not differentiable anywhere that it's straight up vertical, which is happening at x equals -3, and also anywhere it's a sharp point, which is at x equals 0.